So question number 63 says AK is an unbounded and strictly increasing positive real number sequences. So AK satisfies all these conditions, and xk is defined by xk equals defined in this manner. So questions is like, which of the following statements are correct? We have given four options. We'll check one by one. So we have written here AK is an unbounded increasing positive sequence and XK defined as follows. Now the first option says, for all n greater than or equal to m, summation k varies from m to n, xk is greater than 1 minus am by an. So now we'll see whether this option is valid or not. So now we'll write down the left hand side of the inequality. So is summation k equals m to n xk. If we open up the summation, we get it as like xm plus xm plus 1 plus etc. plus the last term would be xn. What is xm? By the definition, we know xk is equal to ak plus 1 minus ak by ak. So xm will be something like am plus 1 minus am by am. Yeah, well, there is a slight change in the, it is defined like this, it is m plus 1. So the second term would be like am plus 2 minus am plus 1 divided by am plus 2. So the terms continue like this, and the last term would be an plus 1 minus an divided by an plus 1. Thus we have the summation k varies from m to n xk as the sum of these terms. What we know about this a, the sequences, we know these are strictly increasing sequence. So am plus 1 is always less than am plus 2 less than etc. an plus 1. They are increasing. So the first term, if we check am plus 1 minus am, since they are increasing, this is a positive quantity, divided by am plus 1, still again a positive quantity. But this am plus 1 is less than an plus 1. So if we change the denominator, we get the inequality as like this, because an plus 1 is less than an plus 1. Similarly, if we replace the denominator for this term and all such terms, yeah, inequality, it becomes like the, it is greater than. So what we are going to do is just to replace all the denominators. So the k, sum varies from k to mxk, will be greater than am plus 1 minus am. The denominator has been changed to an plus 1, and plus the second term also, the denominator has been changed to a greater value, an plus 1, and so on to an plus 1 minus an, the whole divided by an plus 1. What we observe is the denominators, currently all the denominators are same, so we can add it together. So what happens if we add it together? It will be like am plus 1 minus am plus am plus 2 minus am plus 1, etc. an plus 1 minus an, the whole divided by an plus 1. So what we have here is this am plus 1 and minus am plus 1 got cancelled out, and again am plus 2 will be cancelled out by the next negative term, and it will be gone like this. So finally we will have this an will be cancelled out from the last term somewhere like here, since the term before an would be like an minus an minus 1, somewhat like that. So an will be cancelled, every terms will be cancelled. So the only remaining term what we have here is am and this guy an minus an plus 1. So the inequality becomes like an plus 1 minus am divided by an plus 1. This is positive, this is negative. So we can, take that term outside. It will be like an by 1 minus an by an plus 1. But we know, an is less than an plus 1. So this term is a greater term. So, and we are subtracting a term. So if we subtract 1 minus am by an, this quantity is bigger than this one. Thus there will be no change in the inequality. So we can replace this with this, and the inequality remains the same. So now what we have is summation k varies from m to n, xk is greater than 1 minus am by an. That is what the first option says, so first option is correct. Now we know these ans are strictly increasing and unbounded. So this am is a fixed quantity, and if we fix this m and if we varies this n, as n tends to infinity, since these ans are increasing and unbounded, it will tend to infinity. So what we have is like a by some am, some finite quantity divided by infinity, which would give like 1 minus 0. So it is greater than 1 is something. So for any m we can get the resist m, the resist n, as n can tend to infinity, and we can get this value approach to 0. So easily we can say this value we can 1 by 2 2, this value which goes to down to 0, it can be 1 by 2, 1 by 3, 1 by 4, 1 by infinity 2. So as n tends to infinity, we get it is greater than 1. So there exists certain n such that summation k varies from m to n xk is greater than 1 minus 1 by 2, that is 1 by 2. Thus, option number 2 is also correct. Now what it remains to prove is whether the series k equals 1 to infinity xk, the property of the series, whether it converges or whether it diverges. By the Cauchy's criteria for the convergence of a series, we know for all epsilon we can get certain n comma n such that k varies from m to n, xk should be less than epsilon for all m comma n greater than n naught. This is the Cauchy's criterion for the convergence of the series. What happens here, just now we have proved that for any m we can get certain m such that xk is greater than 1 by 2. So that summation of this partial sum is greater than 1 by 2. So it can never be, we cannot find any n such that the series, the partial sum is less than epsilon. So as n tends to infinity, this summation is always greater than 1. So it does not satisfy Cauchy's criterion, therefore it diverges. So third option is wrong and fourth option is correct.